we, the Mathgicians, are going to present about the discrete mathematics contribution. Our group consists of 4 members, which are Chin, myself Moon, Seetha, and Rose. A brief introduction about discrete mathematics. Discrete math is a branch of mathematics dealing with objects that can assume only distinct and separated values. Discrete math is in contrast to continuous math, which work with structures whose value might vary over the real numbers or have some non-separable property. Discrete structure can be counted, arranged, placed into sets, and put into ratio with one another. Learning a variety of various problem-solving techniques and then being able to creatively combine them to arrive at a solution are two of the fun things about exploring discrete math. About half of the computer science, operation research, and pure mathematics are based on discrete math. Discrete math is being used in an increasing number of applications in industry and academia. Everyone is connecting to mathematics at all times, hence discrete math is a natural element of everyday life. The first application of discrete math in real life that we want to introduce is the graph. The graph is a structured representation of discrete mathematical data that use edges to connect distinct network of nodes. The two fundamental sets in the graph are edge and nodes, which an edge connects two nodes. Graph is one of the easiest and significant ways to interpret discrete mathematical data in mathematics, and it brings a lot of benefit to our real-life application. About the history of graph theory, the basic idea of graphs were first introduced in the 18th century by Swiss mathematician Leonhard Euler. His attempt and eventual solution to the famous Königsberg bridge problem depicted below are commonly quoted as origin of graph theory. The German city of Königsberg is situated on the Prigolia River. The geographical layout is composed of 4 main bodies of land connected by a total of 7 bridges. The question posed to Euler was straightforward. Was it possible to take a walk through the town in such a way as to cross over every bridge once and only once, also known as a Euler walk? After a few attempts on drawing the path in graphs, the branch of math known as graph theory lays dormant for decades.
Graph theory is a key component of discrete mathematics, which is a significant area of practical mathematics. In today's world, it has a wide range of applications. We will illustrate some direct application of graph theory in use. Google Maps use discrete mathematics to determine the fastest driving routes and times. The connection between them are distance-based edges. Optimal path is determined by software. The efficiency of including every vertex in the road is demonstrated via a Hamiltonian path. The traffic accumulation data problem needs to be mathematically modeled using a straightforward graph in order to examine traffic control issues at any intersection. The communication link between the set of vertices at an intersection point will be represented by the primitive map edges. In the traffic control graph, an edge will join the traffic stream that may move concurrently at a corner with no differences. An edge will not connect streams that are not capable of moving together. The role of traffic lights is to turn green, red, yellow lights and time the interval between them. Graph theoretical concept is used to clear road blockage. When the road in any town or city are blocked due to snowfall, planning is essential to ensure that the roadways are clear to put salt. The streets are then efficiently navigated using Euler circuits. Making efficient use of the broadcast spectrum for mobile phones uses linear algebra and information theory. Assigning frequency so that there is no interference with nearby phones uses graph theory. We uses discrete mathematics to decide how to explain train rail lines, train timetable scheduling, and scheduling of the crew members and equipment for train trips.
Biggest impact graph based on real life. Internet. The Internet in the world's most extensive and largest network ever devised by humankind. And Internet is thought to be a gain virtual graph. In research engines such as Google, Yahoo, Bing, and others, it it searches for web pages, where web pages are linked to each other on the internet via hyperlinks. In the graph, every vertex represents a separate web page, and and every edge of represents a link between two pages. It's important to note that links only go one way, so this graph is directed and extremely large. Recommendation engine. Recommendation suggestions are a fantastic way for a platform to encourage users to stick around and keep browsing. Many companies are using graph theoretic data structure to keep user hooked, linked. How you connected Facebook, people you may know. We don't need a lot of resource to begin working with graph, and they can be tremendously useful. Using user data to build a graph where each node is product and each edge is relation between two products. Each node in the graph has weight that will be used to compute the graph edge of weight. Combination and permutation. The concept of counting, combination, and permutation are in a variety of contexts. The many configurations that may be created from the given collection of items are counted as permutation. As much as order sequence matter in permutation, the specific to do it is vital to note that the order in which the names of three nations are written, whether it's PU, USA, Brazil, Australia, or Australia, USA, Brazil, or Brazil, USA, sorry, Brazil, Australia, USA is different. The order of consequence is irrelevant when the names of three different nations are combined. They form a single group. The techniques used to determine how many outcomes can combinable in certain circumstances are permutation and combination. Combination and permutation are referenced to as choice and arrangement respectively. The sum rule and product rules, which are based on the basic of concept of counting. History of combination and permutation. The origin of Jainis in India and maybe much early can be treated back to the ideas of permutation and combination. But Jainis deserve a credit for treating the issue as stand-alone mathematical topic under the terms of Vaikapa. Mahavira is possible the first person in history to be credited with developing a general equation for permutation and combination. In his medical treatise Shuhrata, written with the 6th centuries, Shuhrata claims that the 6 different tested may be combined in 63 different ways and consumed one at a time, two at a time. Sanskrit scholar named Pingala, who lived in 3rd century BC, described how to count the possible combination of given numbers of.
Let's start with combination and permutations application to today's life. First application will be phone numbers. In phone number, there are total 8 digits, in which first 2 represent the area code and next 2 represent the city code, so the first 4 digits are fixed. Next 4 digits are permuted to form the new number. Next, cracking codes. Understanding permutations can help one in the science of breaking or creating codes, also called cryptography. For example, breaking a code involves guessing what the characters, letters, digits, etc. of a string are and in what sequence. Permutations give you all the possible ways in which the string can be formed. By checking each of these, one can break a coded string. However, this process called brute force can take a long time even with a computer, especially if the code is very long. To make codes, such as passwords, difficult to break or guess, it is usually recommended that people choose lengthy passwords with the widest variety of characters. Lottery number. In the game of lottery, the number reselected, like if someone has to select 4 numbers from first 14 natural numbers, he has to select the digits in a non-repeated manner. The last application would be selecting nominees for student councils. In selection of nominees of the student council, positions are fixed, as president can only be selected from the 12th class and the left positions from the 11th class students are selected on their basis. Let's move on to the biggest impact combinations and permutations based on real life. First impact would be languages. Combinatorics and natural and artificial languages have many similarities. This is due to the fact that the building blocks of the languages, like words, letters, and atoms, are combinations of smaller pieces such as phrases, paragraphs, programs, and blocks. For instance, a string searching algorithm may use word and character combinations. This has direct uses in word processing and database. Performance evolution of these string searching techniques is another significant application area. Combinatorics is significantly used in the study of computability of what we can calculate and how it is performed. Next is operations research. Operations research frequently uses combinatorics to solve optimization issues. In order to reduce overall processing time, cost, and other factors, the task scheduling problem is fundamentally a sequencing problem. Jobs in this area might be found in a processing facility, network, or computer system. The arrangement of vertices and edges is an important topic in many graph and network-related topics. The challenge for a traveling salesman is to choose the best sequence in which to visit places in order to reduce overall distance. To identify a sequence is the graph's shortest route issue. We are at the end of this presentation, which is the conclusion, where discrete math is needed to see mathematical structures in the object you work with and understand their properties. This ability is important for software engineers, data scientists, security and financial analysts. We cover the basic notions and results, such as graphs, permutations, and combinations that are universally needed. To deliver techniques and ideas in discrete mathematics to learner, we extensively use interactive puzzles especially created for this specialization. To bring the learner's experience closer to IT application, we incorporate programming, example problems, and projects in a course. Thank you.